Alright, so we are going to graph this function, which looks kind of crazy right now, um, by applying a sequence of transformations to a very simple function. The original function is y equals x squared. I don't know if that's hard to see, but there's the x, there's squared. Everything else we can describe as a transformation of this original function. So this negative 2 will be a vertical reflection plus a vertical dilation. This 1/3 will be a horizontal dilation. This minus 3 will be a horizontal translation. This minus 2 will be a vertical translation. Right, so all that extra stuff we can see as transformations of this original function. So we'll graph this, um, and then we'll do all this stuff to it to graph this. Um, so let's first identify what transformations need to take place. Okay, and I have these grouped by vertical transformations and horizontal transformations. And you can identify the vertical transformations or changes because in the equation, the things that correspond to them are happening outside of the function. So if you view this function as a box, and you subtract 2 from the box, or you multiply the box by 2, these are all things that are happening outside of the function in the equation, and they correspond to the vertical changes. Likewise, if you view, let's see, um, like this x squared as a box, if you um, multiply x directly by something or subtract something from it, you're doing stuff inside that box. That corresponds to the horizontal transformation. So a horizontal compression, a horizontal dilation, etc. So let's identify what's going on. First, kind of a little tricky thing is that is this business with reflections, where you flip the whole graph across the x-axis or the y-axis. Um, if this vertical reflection is an outside transformation. So if you make the whole function negative, you're looking at a vertical reflection. It's going to flip the whole graph upside down. There's this negative here, and but it's not making the whole function negative. So just to clarify the situation, I'm going to rewrite the function as negative 2. I'm just factoring out a negative 1, if you will, or the sign there. Okay, so I factored out a negative from this part of it, and I'm going to factor out a negative from this part of it. Okay, so this whole thing is negative now. So I know that if I take this graph and make it negative, I take this graph and I flip it upside down. This just clarifies the situation. So in other words, if I take a negative 1 and multiply it by this stuff, I get negative 2, 1/3 x minus 3 squared. And if I take a negative 1 and multiply it by negative 2, I get plus 2, right? Hopefully that step wasn't too confusing. I just did it to make it clear what kind of reflection is happening. Okay, so let's piece out more of what's happening here. So we know there's going to be a vertical reflection. We're going to take the graph, we're going to flip it upside down. Okay, so let's see. So and that's what this is saying. This 2, I'm multiplying outside of the function by 2. So let's see what that corresponds to. It's some kind of vertical thing, and it's this. If I multiply a function by a factor of 2, that means I'm vertically dilating it by a factor of 2. I'm stretching it upwards so that's twice as tall as it used to be. So let's do vertical dilation by a factor of 2. Okay. Oops, forgot my x in here. Let's see. We've got a vertical shift up, a translation up by 2. Translation up by 2. So that takes care of that piece and that piece. So let's look at this inside stuff. 1/3 x would be horizontal dilation by a factor of 3. So if I have 1/3 times x, that corresponds to a horizontal dilation by a factor of 3. And if that doesn't make sense, maybe review just dilations in general, how those work. So by a factor of 3. So I'm going to dilate it and make it 3 times as wide as it was. So that's this piece. And then finally, x minus 3. It's a horizontal shift to the right by 3. And actually, what we probably want to do is we could clarify this further by putting some parentheses here. So it's 1/3 times x minus and then 9, because 1/3 of 9 is 3. So we've got a horizontal dilation by a factor of 3, and then a horizontal shift or translation by 9 units. Alright, so here's our list of what we need to do to y equals x squared. Now the question is, in what order are we going to do that? So you want to do the dilations first. So let's do it in this order. Dilations definitely before. You want to do the shifts, the translations after the dilations. So we'll do the dilations, translations, and then reflection. We'll just flip it. We'll do everything and then we'll just flip it over. Okay. Definitely do dilations and compressions before you do translations, just to keep everything straight. Okay, so this is kind of our list of what we need to do to y equals x squared. So let's just go ahead and graph y equals x squared. So that's pretty simple, right? It's going to be something like that. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. 2, 4, and then okay, so I'm going to draw my curve here. It's not going to be a perfect parabola. Alright, so let's make that. That's the original one. Okay, so let's do our dilations. We can do horizontal or vertical first. Doesn't really matter. So we're going to horizontally, let's just do the horizontal dilation by a factor of 3. That means we're going to take every point and take its distance from the y-axis and multiply it by 3. So this to me these points are very easy to see. So this has a distance of 2 units away from the y-axis, so it's going to be 6 units away. 1, 2, 3. Let's see. Sorry. Yeah. So 1, 2, 3, 4, 5, 6. So that new point is going to be over here. This is 1 unit away, so the new point is going to be 3 units away. 1, 2, 3. This is 0 units away, so it's going to remain 0 units away. So 1, 2, 3, and then 2, 4, 6, like that. So let me, well, so you can draw new points, then sketch a new graph. I think I'm going to copy. I was thinking about just transforming this one, but I want to leave evidence of where we've been. So I think I'll make copies. Just make them different colors. See if I can stretch it enough. Yeah, something like that. So that was our horizontal dilation. Let's cross that off. Let's do our vertical dilation by a factor of 2. So these points to me are easiest to see. So for vertically dilating by a factor of 2, we'll take these distances from the x-axis, so 1, 2, 3, 4, and multiply them by 2. So this point is 8 units or 4 units away, so it's going to be 8 units away. So it's going to be up here. This one's 1 unit away, so it's going to be 2 units away. 0, 2, 8. So let's copy this. Make that a different color, something like that, let's say, and then how are we going to do this? Let's see if that did anything. See, I need to scoot it down so I have room to stretch it more. Is that it? Oops. Yeah, there we go. Just making sure we hit our new points. Okay, so we did our vertical dilation. And then let's do our vertical translation. So we're done with our dilations. Let's do our vertical translation by 2. That means just take every point and shift it up by 2. So that's very easy. The whole graph just shifts up by 2. So I was moving it because I think I accidentally moved it horizontally too. Yeah, so this point went from here plus 2, here plus 2. Let's make that a different color. So that's our vertical translation. Horizontal translation by 9. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. It's gonna be off the screen. Sorry about that. So you take every point and add 9 to its x coordinate. So it's, this point here at 0, 2. I would 1, 2, 3, 4, 5, 6, 7, 8, 9. That point at what is that 3, 4. Add 9 to it, so its x coordinate is 12. Okay. So let's oops. Make a copy of that. See, we're kind of running out of colors. Okay. Let's shift it over from what we had by 9 is like over there. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9 ish, roughly. And then that was our horizontal translation. We did our vertical translation. The last thing is vertical reflection. So the way you do that is you take the distance of every point from the x-axis. So like this one looks like it's 3 units. 1, 2, 3. I might not have it lined up perfectly, but this is the idea. So 3 units away from the x-axis. So this from this mirror line. So the line across which you're reflecting it. So then the corresponding point would be 3 units away in the other direction, away from the axis. So that would be my new point. Let's say, where's another? I'm kind of off the screen here. So if this is 4 units away, 1, 2, 3, 4, then it would be 1, 2, 3, 4 in the other direction. And then what you'll get when you do that is so I'll just take this and flip it vertically. What you get when you do that is, oh yeah, that would be vertically with respect to this line here, but I'm doing with respect to the x-axis. It would be something like that. So here's our final function down here somewhere. And we got to there by recognizing what transformations have taken place. What have we done to y equals x squared to make it into this mess? And then when we do each one of those things to y equals x squared, we end up with this graph down here.